Hello again everyone, welcome to another mobile robotics video. This is being recorded right after I recorded the last one, and it should be uploaded right after the last one as well, so it hasn't been too long, but this tutorial is going to be on sensors, which are basically used by mobile robots to detect various values, and these values are used by the robot to act out whatever it needs to do, or to collect data or anything of the sort. So let's get right into it. Let's say that mobile robots use sensors to measure internal/external values. So either robots parameters or environmental parameters. And where of course the internal values are the robot's parameters and the external values are the environmental parameters. And sensors basically they allow the robot to increase its productivity, flexibility, safety, and efficiency, time efficiency basically. Improving these sensors improve all of these values, basically all of these aspects for the robot. Now of course when I say sensors allow the robot to increase all of these aspects, sensors are required, but I mean to say improved sensors. So a better way to say that would be to say improved sensors allow the robot to improve all of these values. So what is the sensing process? Well, to start with, the robot is going to make use of a transducer, which converts a physical or chemical quantity into an electrical signal. Quantity into an electrical signal. Then the sensor uses a signal conditioning unit. So signal conditioning this is used to ensure a linear relationship for the sensors, for the measurements of the sensor. So we want whatever the measurement is to go up linearly or down linearly, which makes it easier to, and which actually makes it possible to actually gauge the output signal. If it just if the measurement was erratic for an increase or a decrease, if it changed erratically, then it may be impossible for the sensor to actually make use of the measured value. So let's say allows measurements. Allows measurements to have a linear relationship so it's possible to gauge the output signal because if we didn't do this, the sensor would require every possible value. So we need the signal conditioning for the output signal to be gouged without every possible value of input. So the signal conditioning unit allows the signal to be linear and proportional to the quantity being measured. And of course the output may need to be amplified. Because making it linear may make certain outputs extremely small. Now the modified signal is output to the computer interface. Now I'm trying to write all of this down as if I were taking notes. So I do use shorthands. And then we have the data reduction and analysis stage. And in this stage, the data is compressed and fused to be able to generate a model of the actual world. And finally, we have the perception stage, which, as you may guess, is the stage in which the robot analyzes all of this data, all of the models. So the robot can understand its surroundings, basically. So the robot understands the state of its surroundings. Or rather than understand, let's say infers. Okay. And we can see this as a top-down layered system where the transducer feeds into the signal conditioning unit, and so on. So the signal conditioning unit will feed into the computer interface, and so on and so forth. So how can we characterize how can we characterize sensors? We know that, to start with, let me real quick make this English United Kingdom. Right, well, I'll take care of that later. Hopefully next time I'll have word on the English United Kingdom by default. I did before, but for some reason it's defaulted back to United States. So we know that sensors can vary greatly in their performance characteristics, where some sensors are extremely accurate in laboratory in a laboratory environment, but may have many errors in real world conditions. So that's why we characterize them, which can help with this. So to start with, let's write that down. Some sensors are extremely accurate in a controlled lab environment, but have many errors in a real world environment, which has more variables, for instance. Or more environmental variables even. So we can characterize these sensors, and let me just make this a bit bigger. Make this one even bigger, because I want things to be nice and clear. So if we have measurement range, then we can say that this is the difference between the maximum and minimum measurement. And then we can have the accuracy, which is the difference between the actual and estimated output. And this is important because this can be confused with precision. So precision is not even precision, repeatability is the difference between successive measurements with an unchanging input. With an unchanged input. I think accuracy and precision, that comes on a bit later, but basically repeatability, as the name suggests, is how repeatable the result the results of the sensor are. So if, let's say for an input of 5, if we get 10 and then 20 and then 30 and then let's 5 as an output, then it's not very repeatable. Whereas if we were to get 10, 11, 9, or so on, it may be more repeatable, or maybe it's a sensor that's that needs to be much more precise than this. But you get the idea. While accuracy is the difference between what the output needs to be and what the output, what we know the output to be, and what the output is measured as. So we could add that as well. And then finally we've got resolution, which is the smallest possible difference between two measured inputs, where they will actually be seen as different. And this can also be called the smallest input that can be observed. Smallest observable input. Right, so beyond this, we have sensor classification. We've got a number of different sensors, such as proprioceptive sensors, these measure internal values of the robot. And then we've got exteroceptive robots. Exteroceptive. Exteroceptive sensors even, sorry. These measure external values, so values from the environment of the robot. Then we've got passive sensors. These listen, so they passively measure energy coming from the environment. And then we have active sensors, which emit energy and they measure a reaction to that energy. And these have better performance usually. These can result in better performance. But they can also affect the environment. So active sensors, for instance, might send out a wave and then measure the reflection of that wave, maybe to measure distance or to see where an object is, model the shape of an object, so on and so forth. Passive sensors might measure the temperature of the environment or something like that, where all the sensor would need is an input of temperature. So I think that's enough for now. Hopefully I'll have another video soon, and I hope you enjoyed.